let's just go ahead and look at the calculator for a moment. If we had two lines, because you're no longer going to be subject to just two lines. So what if I had x plus 3, and then I had negative 3x minus 2. They should intersect in how many places? 1. And they do. They intersect right here in one place. Yes? Say that again? Yeah, you need to take it out of polar. So if you're right here, your function should read function, no longer polar. And you should be in normal. So if you're not sure, you can always do the reset that I've taught you for tests. You could reset it that way. So do make sure that you no longer have it under polar. And then these are the ones, I just picked those out of my head. So you got lines and they could intersect in one place. Well, what if I went here and I cleared that out and instead I had x minus 2? Where do you expect those to intersect? X plus 3 and x minus 2. Why don't they intersect? Oh, because they're parallel lines. So it's possible that they have no intersection, which means that they have no solution, right? Or you've been used to in the past, what if I made this 2x plus 6? Oh no, 2x plus, oh, let's go back. So let's make this 2x minus 4. What do you expect the solution for these to be? They're not parallel, they're not perpendicular.
Coinciding.
They are coinciding. Nice use of vocabulary, Buckman. Well done. Oh, what just happened? Did I have a sign issue in there? That should not have happened. Oh, whoopsies. This is not going to work because what would be the other side of my equation? Oops. It should be 2y, right? So, all right, so let's clear that out. So in your calculator, you're only going to end up putting, I wasn't thinking, sorry. So we've got x minus 2 and x minus 2. Those are going to give us the same line, right? So what's the solution to that? Same line? How many places does it intersect itself? Infinitely many. So that's the number of solutions that you have. Well, what if I had a parabola instead of this line? So what if I had x squared minus x plus, well, let's make it, I don't know, minus 6. We'll see if this works. So there's my parabola. Yeah, it should work. And here goes my line. How many places does that line intersect the parabola? 2 times, right? 1 and 2. So you're no longer going to have just one solution, so you could have 2 solutions. What if this line intersected right here, went this way, just along the vertex? How many solutions would there be? Just 1. Or I could have this line go all the way down here, so we could change this to x minus, bless you, x minus 8. So here's a parabola. And then there goes a line. Will it ever hit that parabola? So that would be a no solution. Could I have an infinitely many solutions with a parabola and a line? With a parabola and a line? Infinitely many? No, because it'd have to be a parabola and a parabola, right? So if I had a parabola and a parabola, and it was the same parabola, then that would be infinitely many. But what if I made the line into another parabola? Whoops. How about if I make it into negative x squared plus 4x minus 6. Let's see what that does. And I'm just throwing out numbers. So here's first parabola. And here's the second parabola. How many solutions? 2. Is there a way for me to get 4 solutions? There is. How? What would this parabola have to do? It'd have to be a y squared, so it'd have to be an opening right or left, and it'd have to go this direction. True? And then it could be no solution if this opens up and this one opens down, but this one's brought down further, right? And it could be one solution if what? If they touch right here at the vertex, but one opens up and one opens down. So you have a lot of different possibilities here, so I'm going to just clear out everything that's in the calculator so that we can use it for later. So those are just some thoughts on what you can do with your parabola. So let's go ahead and look at our notes for today. So we're going to look at the substitution method first. So with substitution, you must have one variable term that has a 1 or a negative 1. And so right here, my coefficient has, that variable of y has a coefficient of 1 or negative 1. So I personally don't like the substitution method. I think it's more work. Your math is more cumbersome. But I will be forcing you to use it on your test. So if your test says use the substitution method, I have to see it because you're going to be tested over it. So even though I probably would prefer to use elimination here, it's quicker, easier, you're going to be forced into that. So make sure that when you're practicing on your homework that you are using the proper method that they tell you to. So for this one, because this is the term that has a coefficient of 1, that's the equation I'm solving for, and I'm solving for y. So my very first step is going to be to solve this equation, 2x plus y equals 5. I'm solving that for y. So I quite simply can just subtract 2x from both sides, and I get y is equal to a negative 2x plus a 5. And so this value for y, this negative 2x plus 5, if the systems actually have a solution, the y values must be identical. They must have a common y value. And so if for this equation here, if the y value is negative 2x plus 5, then this y value on the other equation is also negative 2x plus 5. And so I'm going to end up taking this and substituting it in for that y right there. And so if you substitute it into the original equation that you got it from, in other words, in this instance, if you went and substituted this into that y there, you're going to have an identity. All of your x's and y's will drop out, and you're going to have the left side exactly identical to the right side. You don't want that necessarily. So step 2, we are going to take the 2x plus, not the 2x plus y. We want the 3x. 3x minus 2y equals 4, and we are subbing in the value here into that y. So we get 3x minus 2, and instead of y, we're putting in negative 2x plus 5 equals 4. Be careful, you are distributing a negative, so you're distributing a negative into the parentheses. So you get 3x, a negative 2 times a negative 2x gives you a positive 4x. And then a negative 2 times a positive 5 gives you a negative 10 equals 4. Combine like terms. So these are like terms, this one here and this one here. And then I'm also going to subtract, no, I don't need to do that yet. We'll maybe do that later. So collecting like terms, I have 7x, bless you, minus 10 equals 4. Don't we add 10? 7x is equal to 14 and divide by 7. So x is 2. So at this point you can take that value of x that we just got and you could sub that into either one of the two equations. It doesn't matter which. You pick which one. Which one do you like best? I like this first equation better because there's no negatives in it. So I'm going to sub into the top one. So then step 3.
Could you also sub it into the one that you just solved the
Yep, absolutely. You can sub it into either one, it won't matter. And so I'm going to sub into the 2x plus y equals 5. So we get 2 instead of x, we're plugging in our 2, and then plus y equals 5. So we get 4 plus y equals 5, and if I subtract 4, what do I get? 1. And so then finally, you must write your answer as an ordered pair. If you don't write it as an ordered pair, it's not correct. And so our final answer is, and write it alphabetically. They won't always give you x's and y's. They might give you a's and b's, f and g's. I mean, you just don't know. It can be any letter of the alphabet. So always write what just happened. Hang on. Did that just disappear? Come on, baby. Aha. There we go. Now we're continuing, yippee skippy. Okay, so let's look at example 2. But this time, what do you notice about example 2 that you may not have seen before or you forget about? You got this x squared, right? So we're still using substitution. I could solve this equation here for y or this equation here for y. Which one would you prefer to solve for y? The second one, it's less complicated. So always go for the less complicated one. So that's where we're going to start. Start at the less complicated. And so we're going to take 2x minus y is equal to negative 1. And we're going to solve that for y. So we're going to subtract 2x. That leaves a negative still in front of the y. And you can write it as negative 2x minus 1, or you can write it as negative 1 minus 2x. It doesn't matter which. But then to solve for y, you're either going to divide or multiply every term by a negative 1. And so we end up with y equaling positive 2x plus 1. And so the value for y that we're going to substitute in, since I solved the second equation for y, we're going to plug this into the first equation for y, but just y. We're not plugging it in for negative y, just y. And so you have to be careful when you plug in behind a negative. So we're going to take the x squared plus the 4x minus, instead of y, you're putting in the 2x plus 1, and then equals 7. So you have to use parentheses. If you don't use parentheses and you just slap the 2x plus 1 behind that negative sign, what's going to happen to the positive 1? It's going to stay positive 1. And shouldn't we be distributing this negative into the parentheses here and here? So what we really have is x squared plus 4x minus 2x minus 1 equals 7. And so at this point, we're going to collect like terms, and I have an x squared here, correct? Which implies what's going to happen. I don't want to take the square root because I also have an x term that's going to occur as well.
Take out.
Well, it's a parabola, right? But what do I do when I have a quadratic? I'm solving for x. How am I going to solve for x? I'm going to have to factor, right? So if I'm going to factor, then one side has to be 0. So in addition to collecting these like terms, I am also going to subtract 7 from both sides. And so I end up with x squared. The 4x and the minus 2x gives me a positive 2x, and then minus 8 equals 0. So this is a nice, easy factoring because the coefficient from the square term is 1. So all I really need to know is since this coefficient's 1, I just need to know what factors of 8 subtract, because it's negative, to give me 2. Well, let's deal with the x squared first. So the x squared becomes x and x, right? So what factors of 8 subtract to give you 2? Yeah, 1 and 8 subtract to give you 7, but 2 and 4 subtract to give you 2. So I know I want a 2 and a 4 here. Don't they multiply to give you 8? So whichever one of these two is bigger, it carries the sign of the middle term, because my middle term needs to be positive 2. So the 4 is bigger, it gets the positive. What does the 2 have to be for them to combine to be positive 2? It has to be negative. And so then you're going to set the x minus 2 equal to 0 and the x plus 4 equal to 0. Cancel. And so x is equal to positive 2 and x is equal to negative 4. So those are your x values for your 2 ordered pair answers. And we are going to go ahead and graph these on our calculator so I can show you where they do intersect. But we have to find the y values, don't we? So we're going to plug. Where do you want to plug into, the first equation or the second? I'd rather plug into the second. You could try the first, but that's a little bit more complicated. So I'm going to take the 2x instead of x. I'm going to plug in this 2. So this 2 right here went in here. And I've got minus y equals negative 1. And so I am running out of room. So I'm going to move my work all the way up here. And on top of that, I'm going to move it over as much as I can. There we go. All right, so I end up with 4 minus y equals negative 1. To solve for y, shouldn't I subtract 4? And so that minus y doesn't go away, so I still have a negative y equals a negative 5. What does y equal? 5. So one of my answers is when x is 2, y is 5. So this is one of my answers right there. Then we're going to substitute in same thing. We're going to do 2 times. Instead, we're going to use our other value right here, negative 4. And so you might want to draw yourself a line that we went up to here. So 2 times negative 4 minus y is equal to negative 1. There's a lot of negatives in there, so be careful. So we get a negative 8 minus y equals negative 1. We are going to add 8 this time to both sides. And we end up with a negative y equals positive 7. So what does y equal? Negative 7. So that means our ordered pair would be when when x is negative 4, y is negative 7. So there's your second answer. So let's keep that in mind, and we are going to look at our calculator. So I'm going to move this to the side, and let's look over here. So let's solve, in fact, let's see if I can move this to the side just a little further so we can see the 2 equations. So if I were to solve this first equation right here for y, wouldn't you agree that I could just switch these? Wouldn't I add a y to the right because I need y by itself? And what would I do with the 7? Subtract it. So in my calculator, I'm going to put in x squared. You put it in as well. Plus a 4x, but minus a 7. And so there's my parabola. And then I want to put this one in. So if I solve this one for y, what am I going to do with the x? Not yet. I want to get y by itself. So I want to get this term by itself. What do you do with the x? So I'm going to have a minus 2x minus 1. And then what does the negative in front of the y do? It changes all the signs, doesn't it? What's the question?
Are you able to add y to the other side?
Yep, we could do that as well. So we could add the y, and we could add the 1. So essentially, what are we going to get? 2x plus 1. So that's what we're going to put in here, 2x plus 1. And so it's going to graph the parabola first. There's your parabola. Boop, boop. And then here comes a line. And we anticipate two solutions because we already solved it algebraically, and here's our two solutions, each place at which it intersects. So if I want to actually find that on my calculator, how do I do that? Do I just guess? How can I do that exactly? So look above the trace menu is your calc menu, so do second calc, and then don't you have an option for intersect? So choose 5. And then you'll see it's flashing on one of the lines. In this case, it's flashing on the parabola. I want to get it close to either this intersection or this intersection, but it's kind of in the middle. So you need to use the right or the left arrow keys to move that along, and you want to get it close to one of the two intersections. So I've moved it close because if it's too far away, your calculator can make an error. So you want to get it close to an intersection, but not on the intersection. And so notice the question here is asking first curve. You can see it here. First curve, yes, so hit enter. Then it automatically is flashing on the second curve, and sometimes if it's a little too close to the intersection, I'll back it off just a little bit. And then I'll hit enter for, yeah, that's the second curve. And then guess, yes, I want it to guess, so hit enter again. And so isn't that one of our answers we came up with, 2, 5? So then when you find the second intersection, which is down here, when you go to second calc and you choose 5 for intersects, it's flashing up here where you were before. So you need to use your left key to get it to the other intersection. So it's going to move it along the parabola. So I'm just going to keep hitting left, 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 left. You can keep it on either side. It doesn't matter. I'm going to just put it above. And then hit enter, because that's where the first curve I want to be. The second curve, they've placed it perfectly. I'm fine with that. So hit enter, and then hit enter for a third time. And that's the intersection. Isn't that the other answer we came up with? All right, so you will not have use of your calculator most likely on your test, just to let you know. But there is a way. What's another way that you could have checked your answers to both of these problems? Yeah, take your values and plug them in. There we go. And then that will enable you to, I mean, they both should work out to give you a true statement, and that just means that they both have that solution, and so they're in agreement. All right, you will have word problems. There's about 3 of them. When you do your word problems, you have to write the equations for the system. They're not given to you. And so oftentimes one sentence is one equation and the other sentence is the second equation, but not in this particular example. In this particular example, we have a total of $12,000 invested. You gotta love this problem. And then, although he'll say it's not realistic, because we're using simple interest. And we also have a total interest of $1180. So one equation, when we do investments, one equation is going to deal with the total amount invested, and the other equation is going to deal with the total interest. So I'm going to let, so step 1, I'm going to let x equal the amount at 9%, and I'm going to let y equal the amount at 11%. You must state what you're letting your x and your y be, because Brendan over here could have let his y be the 9% and the x be the 11%, which is fine, but his x and my y are different answers, but overall we're answering how much was invested at each particular percent, and that's what's important. So you're not going to have an ordered pair answer for this one. All right, so then step 2 is to actually write your system. So look at the amount that's invested. I have a total amount invested of $12,000. Do we know how much was invested at 9% and how much was at 11%? But we know that we have a total of $12,000. So how are you going to write that and show that? Okay, so let's write that as x plus y is equal to $12,000. Right? And then how am I going to show that the total interest is $1180? Well, let's just talk about the interest at 9%. Let's just say that I knew I had $100 at 9%. How would I calculate the interest? $100 at 9%. How do you calculate the interest, though? How?
9 divided by.
But you're not telling me how. I don't know what of means. If I have $100 and you're getting interest, we are not going to be dividing to get that. It is 100. thank you, not 5.9 though, it is 100 times the interest rate in decimal equivalency, right? And so the decimal equivalency of 9% is 0.09. So we're going to multiply x times the interest rate to get that. Oh, Stacy Bravo's birthday. Happy birthday, Stacy. All right, so to get my interest, I'm going to take it'd be handy if I were here, 0.09 times the amount invested at 9%. That's going to give me the total interest for that 9% investment. Then I'm going to add to that 0.11 times the amount invested at 11%, and the total interest should be $1,180. There's my system. Now, me personally, I probably wouldn't use substitution to solve this, but you don't have a choice. We're gonna use substitution. So, you can solve for x or y. It doesn't matter because both x and y have a coefficient of 1. For chuckle's sake, let's solve the first equation for x because I don't want you always thinking we have to solve for y. So, step 3. We're going to solve that equation for x. So x plus y equals 12,000. If I get x by itself, don't you just subtract y? So x is equal to 12,000 minus y. So we're going to take that amount and we are going to plug it into, or substitute it into, the other equation's x value. So that's going to be our step 4. Step 4. So we're going to take 0.09 times, and instead of x, we're putting in 12,000. That is a terrible 12. So 12,000 minus y. And then plus 0.11y equals 1180. So use your handy dandy calculator. So take 0.09 and multiply it to 12,000. So from here to here, we get 1,080. And then 0.09 times a negative y gives you minus 0.09y plus 0.11y equals 1180. Then we have like terms. So what's a negative 0.09 and a positive 0.11 can give you? So we get plus 0.02y is equal to 1180. And then if we subtract 1080 from both sides, what do we get? Yep. So we get 0.02y is equal to 100, and then to solve, we're going to divide both sides by 0.02. And shockingly, that doesn't give you like $200 or anything. It gives you 5,000. Is that a reasonable answer? How much was invested total? 12. So that's a reasonable answer, 5,000. It's less than 12, which that's what we're looking for. And so step 5, we're going to substitute that in. So what would you rather substitute in? The first equation that you made or the second equation? Okay, but what are you going to substitute it in? The first equation, I would be. Juan? Okay. Waiting. Where are you at there? Okay. So write a sentence answer. So we're going to sub into the first equation. Bless you. And so because it's a word problem, you're not going to write an ordered pair as an answer. You have to rewrite the question as a statement. So the question says how much is invested at each rate. And so the last thing that you're going to do is answer that question. And so let's get a pretty color. And here's where, and this is why we're going to answer the question as a complete sentences, because you could have set up your x as the 11% versus my x as the 9%. And if you answer it and leave that as your answer, that doesn't really answer the question, because I could have had, wait a minute, my x was 5,000. My y was 7,000. So we have to state what we found. So how much is invested at each rate? Therefore, so you can use your triangle of dots, therefore, $7,000 was invested at, so 7,000 was my x, so at 9%, and 5,000 was invested at 11%. And so Math Excel won't necessarily require that, but I will on your test. So any questions about substitution? Now if I were to graph this on my calculator, how would I graph this on my calculator? Because I can graph it on my calculator. What would you have to do here? Solve for y, so you would put into there the 12,000 minus y, or 12,000 minus x it would end up being, right? And then this would be a little ugly, wouldn't it? But you could solve it for y, couldn't you? And then they should intersect at 7,5 or 5,7, depending upon what you made your x and y at. All right, so let's look at the back of this page. Elimination, much easier, much quicker. Math is easier. Love it. So you have to make a decision. Are you going to eliminate the x values, or are you going to eliminate the y values? I make that determination on which is less work. So on this one, consider the 5 and the 2 as denominators in a fraction. So something over 5, something over 2. What would you have to make those denominators into? 10. So that means I would have to multiply this equation by 2 and this equation by 5. And one of them would have to be a negative, because I want my coefficients to be the same number but opposite signs. And so, so that's a lot of work to multiply both equations. But here, notice how I already have a plus minus? That means I won't have to multiply anything by a negative. So with a 3 and a 4, what would I make those into? 12. I still have to multiply both equations by something, but I don't have to multiply by a negative, and I far prefer that. So I'm going to eliminate y's. If you want to eliminate the x's, that's fine. You go right ahead. We should still get the same answer. But I'm going to choose to multiply the first equation by what? Positive 4, and the second equation by positive 3. No need for any negatives. And so this is step 1. So step 1 is deciding what you're going to eliminate. And then you're going to go ahead and distribute and rewrite the entire system. Don't just try to scratch things out. That's where mistakes are made. So 4 times 5x is 20x. 4 times the 3y is positive 12y. Equals, and don't forget to multiply the 4 to the 9. So 4 times 9 is 36. And then the second equation, 3 times 2x is 6x. 3 times negative 4 is negative 12, and that's where the elimination will occur. And 3 times 14 is 42. And so we are going to add. I always add, I never subtract in elimination. And then don't your y's cancel out? And you're left with 26x equals 78. And we're going to divide by 26. Now at this point, I really don't know if 26 goes into 78. You may or may not have a calculator. Probably won't have a calculator on this section of your test. So let's talk about what divides into 26. What numbers? That's a smaller number. 2 and 13. 3 doesn't go into 26 because 2 plus 6 is 8, and 8 is not divisible by 3. So 2 goes in there 13 times. So I don't know if 13 goes into 78, but I do know that 2 does. So what's half of 78? 39. And half of 26 is 13. And doesn't 13 going to 39 how many times? 3 times. So I know that one of my answers, x is equal to 3. Now, you decide what you want to plug 3 into. Do you want to plug 3 into this x or this x? Which equation looks nice? They're both equally detestable, but which one looks nicer? The top one, why? There's no negatives. So I agree with you. I'm going to choose that one. So the second step is to plug the value we just got into whichever equation you want to. And we've decided to plug it into the second equation. So we get a 6 minus 4y equals 14. If we subtract the 6, we get minus 4y is equal to 8. And then divide by negative 4, what do we get? Negative 2. And so there's my second part of the solution, but is that my actual solution? Can I leave my answer like that? No. So you have to finish off your answer by writing it as an ordered pair. So alphabetically, x comes before y. So we are going to write it, final answer, as 3, negative 2. And of course you could graph those if you wanted to, we're not going to. So now example 2, technically you could solve that using substitution, but quite honestly, that's more work than what we're going to do here. If you wanted to eliminate your x's, what would you have to make them both into? 2x. So that means we only have to multiply this equation by what? Negative 2. You'd have to multiply by a negative because you want opposite signs. Oops, thank you. Okay. Come back, airplane. Why do you keep disappearing on me? And there we go. Okay, thank you. All right, so what if I wanted to eliminate my y's? What would I have to make those into? 6, but I'd have to multiply both equations by something. So in my world, it's less work to eliminate the x's. So I choose to multiply only the second equation by a negative 2. You can eliminate the y's if you want to. It's just more work. So rewrite the entire system, even the equation that you didn't touch. And then distribute the negative 2, so you get negative 2 times x is negative 2x. Negative 2 times 2y is negative 4y. And negative 2 times 5 is negative 10. And so now when you add, your x's cancel this time. You're left with a negative 7y equals negative 7. So what's y? 1. How are you going to find x? You're going to plug into the first equation or the second? Okay, so this was step 1. Step 2 is to use substitution. So, and again, you can plug in the first if you want. I also like the second. So x plus 2, instead of y, we're putting in the 1 that we just found, equals 5. So we get x plus 2 equals 5. What does x equal? 3. So this is the second part. And so finally, your answer alphabetically is 3, 1. Final answer. So we like elimination a whole lot better, don't we? Right? But it's not always straightforward. Look at example 3 and 4. Let's find out why. So if we were to eliminate the x's, what would you make the x's into? 4, and that means we'd have to multiply the top by just a positive 2. What would you do if you eliminated the y's? What would you make them into? 6. And so again, we'd multiply the top by 2, so we really don't have a choice. We're multiplying the top equation by 2. And so we're going to rewrite, so this is our first step here. So we get 4x minus 6y equals 6. rewrite the second equation, even though we didn't touch it. What happens on the left? Both the x's and the y's cancel. You must tell me what is left over. The left side has a value of 0, doesn't it? What does the right side have a value of? 12. So you have to write that statement. Because remember we talked earlier, this is a system of two lines. So either the lines are parallel and don't intersect, or the lines are the same line and they intersect infinitely, or the lines intersect in one place and then we would have a solution. Well, when the x's and y's drop out, you have no solution. So is this statement true or false? It is false. 0 does not equal 12. So if it's a false statement, what's your solution going to be? No solution. And so what kind of lines are these? They are parallel lines. So example 4 is very similar. If we were to eliminate the x's, we would have to make them into 4. So what would we multiply the top by? Not 2. -2, and these would be 6's, and we would also have to multiply that top by a -2 as well. So on this one, instead of multiplying by 2, we're going to multiply by -2. And let's see what that does for us. So we get a -4x, a positive 6y, but it equals a -6. The second equation remains unchanged. 4x minus 6y equals 6. But this time when we add them together, what happens? We still get the left all canceling out. And doesn't the 6 and the -6 cancel out? So what's the value of the left side? 0 equals the value of the right side? 0. It is possible that you can have 4 equals 4, or 12 equals 12, or -7 equals -7, depending upon how the question was written. But then ask yourself, is this a true statement or a false statement? Yep, this is true. So if it's a true statement, what's your solution going to be? Infinitely many. Oops, cancel. Sorry about that. Now they might ask you for a particular solution. What kind of lines would these be? Coinciding, same line. So if they ask you for a solution, I personally, if I'm given a choice, I would let x equal 0. Because if x were 0, that makes that go away, and then what would y be? I'm covering that up because that's going to go away. Y would have to be what? -1. So one of your solutions would be 0, -1. That's just one possible solution. And what would be 4 times 0 here? 0, and -6 times -1 does give you a positive 6. So it does work on both equations. Any questions about elimination? All right, you could have a word problem that involves elimination as well. You can make that choice when you get to that.